Now, people also get confused with this VQ mismatch and this whole idea of dead space. So let's start out with the dead space. Now, technically, if we had some sort of, remember, we're saying restrictive lung diseases, we're having a problem with diffusion. We've thickened this membrane here, so you're not able to diffuse the oxygen across. So what you actually did is you actually increased dead space, right? This right here would be your normal dead space, right? There's no actual, this is the conducting system. There's no actual oxygen exchange across it. Now, if we had some sort of restrictive lung disease, where the blood is not going, the air is not going to go through this diffusion gradient, we actually increased our dead space, right? Any portion of the lungs that's not going to have oxygen or diffusion going across it is considered dead space. So in essence, if there's any decrease in this diffusion capacity of carbon monoxide, we're saying we increase dead space, okay? So I want you to keep those two, I know this is a good bit of review, but I want you to keep those two separate. Now, another concept that was a bit tricky, let me clear this real quick. Let's see, so if we, this idea of this VQ mismatch, right? So when we talk about ventilation, it's ventilation over, sorry, it's a Q, not a P, and that's ventilation over perfusion. So one's going to have to be the problem, right? Are you having problems getting air in, or are you having problems perfusing the lungs with blood? Either way, you're going to have this mismatch. Now, one of the tricky things is if we look at kind of like a larger alveoli here, what I had confused for a while is this idea of shunts, right? Now, if you had some sort of mucus plug here, right, that's considered a shunt, okay? This is a shunt. I know that they talk about shunts in the heart, and you kind of think of the idea of shunting blood around as being a shunt. But when we talk about it in the lungs, the shunts are considered air blockages, okay? What I'm trying to say is that if the lung was clear and you had a pulmonary embolism, for instance, right? Yeah, well, let me put it over here, right? You had a pulmonary embolism, so blood cannot go across here. This is not considered a shunt, okay? It's considered a pulmonary embolism. So anytime they talk about a shunt, they're talking about some sort of air blockage. So I had that confused for a while. So just keep that in mind. When you're in the lungs, the shunts are regarding to some sort of blockage in ventilation. Now, granted, if you did have something, shunt, some sort of air shunt, say some sort of mucus plug or foreign body or whatever, right here, what happened to your dead space, right? You actually technically like decreased it, right? Because this area would have been dead space too before you get to the diffusion component. So technically you decreased it. Okay, I haven't seen any questions like that, but it just gets the point across that this is the idea of a shunt. Now, some other terminology you may come across is is this idea of this VQ mismatch. So whenever, if you do the math, you can figure out that if there's a problem ventilating the lungs, say you have some sort of mucus plug or whatever, then the numerator is going to go down. Now your perfusion's fine. So anytime they say the VQ is approaching 0, that means you had a problem in the numerator, right? So you have a problem ventilating the lungs for whatever reason. Now, if they say that if you have a problem perfusing the lungs, some sort of perfusion problem, if there's some sort of heart defect or whatever, and you're not perfusing the lungs properly, some sort of shock or anything like that, then the VQ is going to approach infinity, right? Because the denominator is going down. Okay, so if you ever see those in the questions, just put V over Q and just work it out in your head what's going on. Okay, I think that's all I wanted to say for that for now.